Hello, dear participants. Welcome to this day 4 of 1 week STTP Technovators 2020. Today, we have planned the session of practical approach to learn applications of computer networks and IoT, Internet of Things. We are very familiar. It is an emerging field these days, and many new technologies are coming. And according to our Make in India, Make for India initiatives, also many cloud services are getting launched and becoming popular. So today's session will be delivered by Mr. Prakash Sontakke sir. Like to take this opportunity to introduce him. Sontakke sir is an assistant professor in the NTC department of the CCOE. He is having 10 plus years in teaching academics and uh, 2 plus years in industry. Sir has did MTech in electronics from College of Engineering, and he is currently pursuing his doctorate in automotive gradient protocols. Sir has wide interest areas right from computer networks, Internet of Things, microcontrollers and programming, and cyber security, etc. So I'm very sure you will learning many things and you will enjoy this. Thank you very much for your participation again. With this, I would like to hand over control to Sontakke sir. Thank you.
Okay, thank you very much, sir, for such a wonderful introduction. So on today, day 4, so I'll be talking about the practical approaches to learn the applications of computer networks and the IoT. So initially, I'll be talking about few concepts of computer networking, and later on we'll be having a hands-on session. So I'll be showing you on a simulation platform how we can create different applications like computer network and certain experimentations on a IoT with the help of Cisco packet tracers, the application tool. So let us begin with the first part of my session. What is by computer networks? So computer network consists of, it's a network of two or more computers which are connected together, and they can communicate as well as they can be used to share some resources. So this is in the form of a kind of information that the one user wants to communicate with other user, or a kind of different devices they are communicating with each other. So normally computer networking kind of application oriented network where the devices are connected to each other via internet. So internet is a kind of abbreviation of internet networking where various devices are connected. So ultimately the application of the computer networks are nothing but we want to communicate with each other. We want to share some information to the people via which is connected on an internet platform. Okay, not only that, but also we are going to share certain resources. The resources in the form of certain hardwares as well as certain software tools. Take an example. If I'm having a certain application tool, is a MATLAB. So I can create a MATLAB as a server, and the different clients can connect it to that particular server via the same application. So in this way, your application can be shared, but also we can share the different kinds of the data via the computer networking. Okay. Now let us see examples. Now see on the left hand side of the PPT, the first topology is a kind of network topology, we can say, how physically the devices are connected. Now see, we can have a set of computers connected via single thick coaxial or LAN cable, Cat5 or Cat6 cable. Okay, here with the help of such networking topology, any information can be shared. Okay, and on the right hand side of my PPT, we are having certain resources in the form of hardwares such as scanner printers. Okay, so single printer can be shared between n number of computers so that the devices can take the printouts or share that particular resources. Depends on the application needed. Now, the next part, why we go for the networking? Why there is the need of a networking first? Now we know that traditionally when networking was not there, so initially computers are remotely placed, and if I want to move the information from one device to the other device, I need to take help of certain external devices, storage devices. So right from the floppy disk, CD-ROMs, or we can now currently we are using the pen drives for moving the data externally. But what if we can use this particular connectivity? If the computers are connected in a platform on certain physical parameters, okay, so geographically how the devices are connected, it might be in a different fashion, and the ultimate game is for these particular applications. So very first one, we are able to share the resources, that is the sharing of hardware such as any computational resources, that might be your disks, printers, scanners, any hardware platform can be shared between number of computers. Not only that, but also we can share the softwares, as I already mentioned it. Any application can be shared with the help of competent networking platform. The second application means the purpose of using the networking is the sharing of the information so that any kind of files or any kind of database we have created that can be remotely accessed by multiple users, such as we widely using a www platform, that is World Wide Web platform, through which we can browse the data, we can browse different websites. So take an example, we are having a google.com. So Google is a server from which we are accessing their web pages with the help of this www, that is the STTP, hypertext transfer protocol. So it will act as a web server, isn't it? So with the help of this we can share the information. Got it? The third one, we can use this networking for the communication between the devices or the communication between the users. We are using our mobile phones, we are using laptops, we are using computers. So ultimately we want to convey certain messages with the help of email applications, or we can broadcast any kind of message with the help of the devices which are connected to the internet. Okay, and finally the purpose of the networking is for a remote computing, isn't it? Suppose I have the hardware server which is remote, then I can able to process it simply at the remote location. I'll be the part of the virtual connection of the server, okay, and then I'll be sending certain commands to operate the destination system. So means what? I'm going to remotely accessing the device as well as remotely sending certain commands of the computational of any program or algorithm associated with the server. Okay, so these are the certain reasons why we go for the networking. Now next one, now depend on this particular component networking perspective, we can classify the network in the following. Okay, the first is based on the transmission media. What kind of transmission media can be used in a computer networking? So very first is a wired kind of media. Any device can be connected with the help of wired connectivity. Okay, wired connectivity also called as the guided media. Okay, so that will provide a conduit from the source to the destination. Means some kind of physical path will be there established between source and the destination. So the wired transmission media can be widely categorized into the twisted pair cables, the shielded or unshielded twisted pair cables. Currently we are using as a CAT cable or a LAN cable to connect different computers in a network. We can also use a coaxial cable. Whenever my requirement of bandwidth increases, I need to move from certain different new cabling technologies or guided media technologies. Okay, so I want to send certain megahertz signals, so I need to go for a coaxial cable, and we can use the coaxial cable probes on the CRO or the DSOs. Got it? This is the coaxial cables. But now suppose I have to send or broadcast a huge data in terms of Mbps or Gbps. In that case, I'll be preferring the optical fiber communication, where the signal can be converted into the light form and that can be propagated into the core of the optical fiber, which is made up of a glass or kind of material. This is one media that will be considered as a guided media. The next one is a wireless. It's open. So wireless, if I'm talking about, there are multiple wireless enabled technologies available, such as Bluetooth, Zigbee. We can have the WiMAX, Wi-Fi, LoRa. We are having so many enormous wireless enabled technology through which we can transmit our data. If depends on the area that can be utilized. Take an example. I need to create a small network, that is the personal area network. So I can prefer your Wi-Fi. So with help of Wi-Fi, I connect all my computers or laptops to the access point or Wi-Fi router, and the data can be exchanged. So this is one particular type of network that is based on the transmission media. The second one is based on your network size. How total size of your network matters. How many computers can be the part of your network. So based on that, your network is divided into three different categories. The very first one is LAN, commonly known as LAN. It is a local area network. So whenever I'm talking about the geographical area, when it will be covering a small laboratory or one small institute where few devices are connected to each other to form a small network, and that will be considered as a local area. Second one, such small local area networks are connected in large manner, and that will be covering your overall city. Take an example of the cable network, television cable network. So that will cover your whole city, and that will be considered as metro area network. Geographical area is not funding. Okay, and finally a wide area network, WAN, so where your whole globe will be connected to each other, and the very popular example is nothing but your internet. Okay, internet is a kind of wide area network. So depends on the size, your network will be divided into LAN, MAN, and the WAN technologies. Now the next one, the based on the management method, means depends on the privilege provided to the devices. Now if I'm talking about a peer-to-peer kind of communication, means both the devices are having the same privilege, just like a computer to computer is a kind of client to client communication or server to server communication, isn't it? Both the computers or both the parties should get the same privilege, just like the student is talking to the student or faculty is talking to the faculty. The second one is a client to server communication, when your client is at lowest priority and the server is at the highest priority, isn't it? So server will provide command, and according to client will process that particular commands. So it's a client to communication, server communication. Okay. Now this is based on your management, and the last one based on the topology, how geographically, how physically the devices are connected, and based on that the topologies can be formed, such as a bus topology. It will create a structure just like a bus. Different computers are connected in a single LAN platform and look like a bus, straight bus. Next one is a star topology. The structure will look like a star, where different computers connected to the single central hub or the network switch. Okay, that will be considered as star topology. Ring, all the devices are connected to each other and form a ring-like structure. Okay, and that is a kind of one topology. Now the mesh topology, every device should be directly connected to rest of the devices by using a specific kind of cable. So here in mesh topology is very much complicated, very complex in nature. Various networking cables are needed in mesh topology. Okay, and finally the hybrid. The combination of all can be integrated and form a simple hybrid kind of network. So depends on our application, depends on our requirement, we can adapt and take or use any kind of topology for having the communication with the different parties. Now, the very basic start the components of your data communication. Whenever I am talking about the data or the components of data communication, we needed at least one sender, we needed a receiver, and the sender wants to send a certain kind of messages in the form of alphabet or numerical values, or special symbol kinds that can be considered as a message that can be propagated towards the receiver. But this message can be sent via certain medium. So this medium might be guided medium or might be the wireless medium, that is unguided medium. Okay, so this medium is again one of the component of your communication. And then one important part, both the parties, that is sender and receiver, should follow certain set of rules. Rule 1 to up to n, that will be considered as an protocols. They should follow certain protocol. So protocols be considered as, these are the set rules that governs the actual communication between the source and the receiver. Okay, so without the protocol, the communication won't be possible. Okay, so both parties should have certain same set of rules on either side. Then and then only communication will be possible. Got it? So these are the 5 components such as the sender, receiver, message, medium, and the protocol. Next one, after the connectivity, let us talk about the data flow. How should be your data flow? Okay, so in the first example, your server, suppose here is a mainframe server, sending a data towards the monitor. Okay, so this particular flow of data is in a single direction. So we can say your data flow is divided into 3 categories. First is the simplex mode, means from one device, the data will be going towards the next device. Take an example, whatever the data is processed by the CPU, that can be shown onto the monitor. Or if I am using a keyboard or if I am using a mouse, it's a one directional connectivity. Okay, means whatever I am typing, whatever clicking on my the keyboard or the mouse, we send the CPU part. It's a simplex kind of communication. Second one is the half duplex communication. Okay, so the data can be sent both the directions, but one at a time. Okay, the first sender can send the data to the next sender, okay, to the next receiver, and once the data is successfully received by the receiver, then the next sender can send the data to the destination system. But it is one after that. Okay, one at a time at least. Okay, so when very popular example of this is nothing but here, you can have your kind of telephone is currently we are considered as in full duplex mode, isn't it? So in what happens in walkie-talkie, we can have such kind of arrangement. One at a time we can talk to the your recipient. Now full duplex mode, both the parties are communicating at in any instant of time, right? Isn't it? So it will be considered as full duplex mode. Currently we are using in our the mobile phones. Now whenever we are talking about connectivity of the computers, the very first point or very first component is needed is your networking cable. So how to prepare a category 5 or category 6 cable, because there are varieties of categories are available based on the database, that is your bandwidth available. So category 1, category 2, 3, 4, 5, 5 is 6. So for important part of UTP, that is unshielded twisted pair cable, how we can trim the cable by our own. So your guide media, your unshielded twisted pair cable is mainly divided into 2 different parts. Okay, the first type is a straight through cable and second is a cross cable. Now straight through cable is nothing but if I want to connect 2 different devices in a network. Okay, let me show you the thing here. On this PPT, the first device is the computer and second device is nothing but your network switch. You can have your router or your laptop. So these are two different devices. If you are having a Wi-Fi router or a network switch, these are the two different devices. So if I want to use or connect two different devices on a network, I can simply go through or use the straight through cable. But again, the question arises, how should I identify whether the cable is a straight cable or a cross cable? So there are different color coding techniques are adopted to identify whether the cable is straight cable or a cross cable. So normally, if suppose we have a cat or LAN cable, so we need to use RJ45 jack on the either side terminate your cable. Now, if I am talking about the color coding scheme, so in your cat cable, total 8 wires are there. 1, 2, 3, 4, 5, 6, 7, 8. Means here we can have here 4 different colors with their opposite white, such as suppose is a brown, brown white, green, green white, blue, blue white, and orange, orange white, or brown, brown white. Okay, in this way you can have here 4 pairs of wires in your cable. Now if you're observing on the first end, we can have some series of color coding. So first is a white, then orange, then green white, then blue, blue white, green, brown white, and brown. Now this particular series, if you are observing on the either side of your cable the same color coding, then we can say it is a straight through cable. Very simple, isn't it? So on either side, the same color coding should be there, and we can say it is a straight cable. So you should know the color coding if you want to cream or create this particular straight through UTP cable, isn't it? So this particular sequence is very much needed or useful for preparation of the straight cable. Now, in the same way, if I want to create a crossover cable, then what is the application of crossover cable? Where we can use this crossover cable? Now, simple case, if I want to use or connect two same devices in the network, an example, computer to computer, laptop to laptop, switch to switch, router to router. If both the devices are same, then we need to strictly use the crossover cable. Now see how this crossover cable can be identified. Now simple way, on both the ends, now see we have a different color codings for the crossover cable. On the first end we have the same coloring that we use in a straight cable. Okay, but on the other side we need to simply follow the different color codings. Now the color coding should be the green white, green, white, blue, blue, white, brown, orange, white, and orange. Now see, here the color coding is different, here is color coding is different. Why we can have such kind of color coding? I'll be showing in the next, or I'll be explaining in the next slide. Out of these 8 cables, how many cables are used actually for communication purpose? Okay, so the one side will be interacted with the other side if both the devices are same one. Now let us see in this example, I have this computer 1, same computer 2, and I'm coming with the crossover cable, isn't it? So means one device is communicating with other device with the help of crossover cable. Now in case one network switch is connected to the different same network switch. Okay, we can have same kind of thing. Here router is connected to the router, so we always go for a crossover cable. Got it? Now ultimately we can say if I want to connect to different devices on network, we can use straight over cable. And if I want to connect two same devices on a network, I need to simply use the crossover cable. Got it? Now let us talk in detail the basic theory behind this Ethernet cable. As I said, in each CAT cable or network cable, we are having total 8 wires or 4 pairs of different color codes. Now in the first left hand side figure, your PC is connected to the hub, network hub. In second case, one PC is connected to the next PC. Now in first case, PC is connected to hub, so I need to use straight cable, that is straight through cable. And sequence is the same as I have shown in the previous slides. isn't it? Now out of these 8, only 4 cables are used, or only 2 pairs can be used to transmit the data or to receive the data. That are, let's see, pin number or cable number 1, 2, 3 and 6, isn't it? And if you are observing the colors, the green and green white and orange white, these are the 2 colors, actually the 4 by accepting the portion of that particular. So green white and orange white, out of 8 only these 4 cables can be used. So first for transmitter positive, second for transmitter negative, third for reception positive, and 6 for the reception negative. Okay, on the same way, if I am sending one cable, first cable for transmission purpose, on the hub, the same one can be used for reception plus. So transmitter plus connected to the receptor, transmitter is connected to the receiver negative, and vice versa. So out of this, pin number or cable number 1, 2, 3 and 6 can be used to send and receive the data in the different computers. In the same way, if I am using a crossover cable, where I can use the crossover cable if I want to connect two same devices on a network. Now suppose this is the first PC and this is another PC. Now I am just using a crossover cable. Then now see pin number 1, 2, 3 and 6. Here the same thing is there, but now see the cables are crossed, isn't it? Now see here the cable number 1 will be here connected to the cable number 3 of the receiver PC, isn't it? And that is why here the transmitter plus is connected to receiver plus, transmitter negative is connected to receiver negative, but in a crossed manner because devices are same. Got it? So in this way, we need to understand in what conditions can use a straight through cable, in what conditions need to use the crossover cable. And if I'm using any kind of cable, out of a cable, how many of them can be utilized for transmitting the data and reception of the data. So pin number 1, 2, 3 and 6 of RJ45 will be used to send and receive the data. Got it? Now the next one. Now once you have this RJ45 and a cable plug, now we needed this particular RJ45 crimping tool. So RJ45, RJ stands for registered jack. Okay, so with the help of this RJ, that is RJ45 crimping tool, we can make a permanent connection between your cable and your RJ45. Got it? And once your cable is formed, we need another equipment that we are observing on your LAN tester. On a right hand side, that will be considered as a LAN tester. Now what it consists of? It is a trans receiver pair. One will act as a transmitter, one acts as a receiver. And if you are observing on here on either side, we are having here numbering 1, 2, 3, 4 up to 8, and that will be indicated by certain LEDs blinking. Okay, so once you connect both the ends of a cable with the help of this LAN tester and start this trans receiver, one by one the lights are blinking. 1, 1, 2, 3, 3, 4, 5, 5, 6, 6 in this way, isn't it? And when it is properly crimped, you will be getting this particular LED blinking, respect LED blinking on trans receiver pair. Otherwise, if your LED is not properly crimped, then we can say whatever the crimping you have done is not properly crimped. You need to again check the connectivity. You need to crimp it properly, and then you can use with the LAN tester to check the continuity between this particular cable. Right? So these are two instruments we needed for preparation of your Ethernet cable. Now let us talk about the topology, the simple and basic things, because if you want to implement it, you should know these background information. So that is why I'm delivering this content. So if I'm talking about the network topology, how devices are connected physically, okay, how we are observing the devices are connected, because connection devices physically and connection of devices locally, these are different aspects. If I'm saying the devices are connected physically, means that with the help of any certain guided media or wired mediums, but I cannot say whether the devices can exchange the data at that instant of time. But whenever I'm saying that the devices are physically as well as logically connected, means they can able to share the information. That is why I'm talking about logical connectivity, device communicating. Okay. So that is why your network topology first. The first part is the bus topology, our central backbone cable. So these are central backbone cable where your devices are connected. It's a thick backbone cable, the coaxial cable. Okay, and with the help of certain taps, the devices are connected. So if this particular cable cut downs, the whole network will let down. Okay, this is the first part in your network topology bus. Second one, we having the star topology where the different number of devices can be connected to the central hub, isn't it? Now this is very, in every institute, in every company, the star topologies can be used because of their enormous advantages. We'll be talking in details about how at the time of simulation of this particular topologies, isn't it? So here what happened, the central part will be considered as a network hub or network switch, having a kind of communication, or the case where what is the difference between hub and network switch. I'll be showing it with the help of certain simulation tool. Now here all the devices are connected to the central device, that is your central hub, and now each can communicating with effectively. Okay? So this particular structure will look like star. But if your central hub fails, your whole network will let down. Okay, your whole network, it depends on this particular central hub or central network switch, isn't it? Now the third topology is a ring topology, where all the devices are connected and form a ring. Isn't it? It's a ring-like structure. And once the data is routed from one to the next to its neighborhood and neighborhood to neighborhood, so host to host, the data is transmitted. But the disadvantage is that if one of the system is goes down, your whole network will let down, isn't it? Now next one, you can have the mesh topology, where all the devices are connected directly with the respective destination different systems. It will create a complex kind of structure, isn't it? So it's again a kind of structure, we can use it, but here the investment is more, where more number of cables are needed here. Next one is kind of tree-like structure. We can have a bus topology as a combination of bus as well as a star topology. Okay, we can consider this as hybrid kind of topology. And finally, a point two, that is the node-to-node communication. Now, before implementing your applications, you should have the basic information about the IP addressing. We can commonly call this IP addressing as a logical addressing. Just like we humans can be recognized by our, in the same, the computers identified by this IP addressing, isn't it? So this, you should have the basic information about what is IP address, how that can be written, and what is the significance of this IP address. Now your IP addresses can be divided into two types, IP version 4 and IP version 6. So we're talking about here IP version 4, and currently we are using in any kind of networking field. So IP version 4 address is a 32-bit wide. Now if you're observing on the bottom side, one example of IP address I've written, that is 128.11.3.31. So it's a decimal dotted form of what you can say, the syntax of IP addressing. Any here 4 decimal numbers are separated by a dot symbol. Okay, so decimal dotted form of structure will be considered as IP version 4. And if you're observing, each decimal number will be having one octet of bits. So here first octet, second octet, third octet, and fourth octet. So here 8 into 4, total size is 32. So the size of IP4 is 32 bit. So how many IP addresses can be generated with the help of IP version 4? It is totally 2 raised to 32, isn't it? So total address space provided by the IP version 4 is 2 to 32. So total 2 raised to 32 computers can be connected in a network, and you can create a huge network, isn't it? So you should know this particular syntax. In which syntax I can write the IP addresses. Suppose I am writing 10.10.10.10. Yes, it's IP address, isn't it? So it should be in a dotted decimal format. But in any industry, institutions, we are using some separate set of free IP addresses. There are certain dynamic addresses are there, IP addresses, certain static IP addresses are there, isn't it? The static IP addresses are provided by the internet service provider and will be considered as a paid kind of IP addresses. And dynamically IP addresses will be the IP address from the ISPs or IANA society. They will be providing these IP address. We can use these IP address free of cost and create our own kind of networks. Okay, I'll be highlighting it in the next slide. So once you have the know the IP address syntax, you should know the different classes of IP address. So here your IP addresses are mainly classified into 5 classes: IP address, IP class A, B, C, D, and E. There are 5 classes are there. Now, if you are observing on the left hand side of this particular figure, class A, B, C, D, and E, how you can identify the IP address class. Now here 4 bytes of information is shown. In a first byte, if your first bit is represented by 0, it is belonging to class A. If it is represented by 10, it is class B. If it is represented by 110, it is class C, and in the same way for 1110 for class D and 4 ones for class E. So out of class A, B, C, D, E, we can use only first 3 classes. Remaining class D is reserved for the multicasting and E for your R&D purpose. So what is meant by multicast? There are 3 different kinds of concept. One is unicasting, second is multicasting, and third is broadcasting. Whenever I am saying the device is communicating using a unicasting communication, means there is only a single transmitter there and single receiver there. Whenever I am saying it is a multicasting, there is only single transmitter is there and a group of receivers are there. They will be receiving the information directly. And broadcasting is a one-to-many kind of communication. Okay, single transmitter is there and all the remaining devices are simply considered as a receiver. It's a kind of broadcast communication. So again, here class A, B, C, as I'm saying, we can use these classes for creation of network. Okay, so on the right hand side, how you can identify the class of IP address. Now see, for class A, it is shown and written as a 0 to 128. So any IP address starts with any number from 0 to 128. We can say it is class A IP address. Any IP address, if it is started from 128 to 191, will be considered as class E IP address. In the same way, any IP address, if it is starting from 192 to 23, will be considered as the class C, and in a vice versa for class D and class E. So in first case, I have written one example of 128.11.3.31. So 128 is the first number, and yes, 128 is lies in particular range. So class of this IP is class B. So what is IP address I have written is a class B IP address. But normally in any institute, in any organization, we will be observing whenever we having certain laboratories, we will be using the IP address 192.168. Any number 1.1 or 12.1. It depends on our requirement. So the question again arises: why specifically we are using the same number? And for your kind So I need to take the what you can say the precautions regarding this. Not able, sir. Okay. 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 Now am I audible to all? Can you please ping in a Telegram group so that I'll be able to understand? Okay. Thank you. Thank you very much, sir. Yes. Thank you. Okay. So I'll be continuing in this particular PPT. So how to identify the IP address? So that is based on the range provided, and you should know these ranges. If the IP address A, the range is from 0 to 127. But what is the purpose of using these classes? Now take an example. I want to construct one network. So if my requirement is I need to connect 100 computers in the network, which IP address class should I choose? As I mentioned earlier, I cannot use class D and class E, both are reserved. But I can use class A, class D and class C, any IP address from this list. Isn't it? But depend on my requirement, that is 100 computers I need to use, so I need to go for class C network. But how I can choose this class C? Because now I like to show the next slide. Now see, whenever I'm trying to give the IP address to the computer, I always provided the default subnet mask to the IP address. Now again, might be coming in your mind, why always need to provide the mask value? That is the default subnet mask value. The answer is, if you know this mask value, you can easily find out the network IP address or the broadcast IP address of the network. So network address will be considered as the very first IP address of your router or your server. Okay, so if I'm having the default subnet mask, and if I'm ending this with the respective address, I'll be getting my network address. And if suppose I have the default subnet mask value, suppose this one. So suppose for class A, the default subnet mask value is 255.0.0.0. 255 means what? Your first octet is full with ones. That is 2 raised to 8 is 256. So as we started from 0, we need to end to the 255, isn't it? So that's why it will be on 255.0.0.0. So how many computers can be connected in a class A? So here see, how many octets are empty? Octet 1, octet 2 and octet 3. 3 octets are empty, means 8 plus 8 plus 8, 24. 2 raised to 24 computers can be used or can be connected in a network. So 0 represents the node and 1 represents the network. How many network can be created? So 2 raised to 8. 256. How many computers can be connected in that particular network? It is 2 raised to 24. In the same way, if I am talking about class B IP address, so here the default subnet mask value is 255.255.0.0. Here 2 octets are full and 2 octets are empty. Whenever I'm talking about the ones, so 8 plus 8, 16. So 2 raised to 16 networks can be created. And how many? What is the capacity of those networks? So 8 zeros and here 8 zeros, 16. So 2 raised to 16 will be the capacity of each network. Okay, so 0 indicates the host and 1 indicates the network. In the same way, now if I am talking about class C, here the default subnet mask value is 255.255.255.0, means here 3 octets are full and 1 octet is empty. So here, how many networks can be formed? So 8 plus 8 plus 8. 1 indicates network, isn't it? So 2 raised to 24 networks can be created, and 2 raised to 8. Now 0 represents your host or computers. So 2 raised to 8 computers can be connected or will be the capacity of your network. So 2 raised to 56. So in class C, I can create a network which will be having the size of 2 raised to 8, that is 256. So if my requirement is 500 computers, I may not be using a class C network. Instead, I can go to the class B network where the size of the network will be 2 raised to 16. But If I want to precisely use it, so I can use, instead of default subnet mask, I should go for classless kind of addressing. That is a different concept we'll be discussing later. And it classless means effectively utilizing. So instead of default subnet mask, I need to go for custom subnet mask. And what you're observing here, CIDR, that is classless inter-domain routing. Okay, so this 8, 16, and 20 indicates how many ones or network bits are available. So here, first case, one octet is full, so 8 are there, so I can tell this by slash. Now from class A address, suppose I am writing 10.10.10.10, I can write /8. So this is the default subnet mask. Okay, if I am writing 172.1.1.1/16, so 172 belonging to class B, and that is why the default subnet of the ID value is /16. These are the abbreviation form of your default subnet mask. Every time I cannot write the 255.255.0.0 for class B. Instead, I can simply write /16 for the abbreviation form, isn't it? And for class C, it is 255.255.255.0, means total 21s are there, 3 are full. So that is why /24 will be the abbreviation value of CIDR. Got it? Now let us talk in details of how to implement this particular net, isn't it? So for this, I'll be using Cisco packet tracer. Okay, so implementation of, I'll first showing you how to implement the start topology using the Cisco packet tracer, and in that I'll be showing you if I'm using the central device as a network switch, what happened, and if I'm using a network hub, what happened. And finally, we're including that particular simulation with why the network switch is smarter than hub. So I'll be giving the visionary how this particular statement is true, isn't it? Your network switch is smarter than hub. How? Now let us talk on this. So I'll be using here the simulator tool as a Cisco packet tracer. So it's you can easily use this particular tool. Your actual working space where you can create any kind of network. Okay, on the most bottommost portion we have certain tools here. So if I having this cursor on this network devices, uh, so different network devices are shown here, such as the router, switches, hubs, wireless connections, any security or emulation kind of thing, isn't it? On the right hand side, I'll be getting here two options, is a real time and a simulation kind of thing. Okay, whenever I want to simulate it, I need to go to this particular tab. Let's simulate one simple example. Suppose I'm clicking on this end device. I need to use, suppose, take this PC. Now this is PC clicking here, and I'll be taking one computer. Okay? In the same way, suppose I'll be taking another computer. So here I'm talking the first slide. If I want to connect to access in a network, I needed a crossover cable, isn't it? So I'll be showing that here also. Here we can have the type of connections. Click on it. Here we'll be observing various kinds of cables, and that can be observed the name or here. Now suppose I'll be having the cursor on this particular black line. So this is a straight through cable. Now see, that is a copper straight through cable. It's shown here. Okay, so dotted dash line is a crossover cable, isn't it? And if you suppose didn't remember what kind of connection I needed, simply can use this particular symbol. Okay, it will automatically find out the type of connection, and it will be selected as a cross cable or straight cable. Now suppose I don't know whether I needed the straight cable or cross cable, I simply use this auto kind of button and simply connect the first computer to the next computer. Now see, you'll be observing the two computers connected with the help of crossover, isn't it? So whenever the crossover cable is there, now suppose I'll be taking another example, using here one computer and the end device, suppose I'm considering as a switch. Now suppose I'll be taking one switch, and now I need to connect these two devices. Now simply I'll be connecting this to this. Now see, the kind of here this will be considered as a straight through cable, and this will be considered as the crossover cable, and that is automatically identified by the device, isn't it? Now once you need to once you have connected these two computers, the very first thing you need to do, you need to provide the IP address to the systems. Suppose for our understanding, I'll be using 192.168.1.1 is the IP address of first computer, and I'll be providing 192.168.1.2 is the IP address of second. This is the only name I am providing, okay, for understanding. But I need to assign the IP address in your actual configuration file. So I'll be clicking on this particular device. Here I'll be showing the CPU. This is the button to start the device. And if you tag it, you'll be observing here LAN port of your device, your headphone, your USB connection, everything just like our actual system. And if you click on a configuration or a desktop mode, you can have this first option as the IP configuration. I can click it here. I need to provide manual IP address, so I can write the IP address here 192.168.1.1. and if I click on this, automatically the type of IP is identified. So the 192 range starts available in Class C IP address. Class C default mask is 3 times 55 and 0. Now see, once I click on the subnet mask, the IP address subnet mask will be automatically identified and run by the device or this configuration. Okay, so I have assigned one IP address to this particular device. I will be clicking on a next. Okay, now go to the desktop using the same utility to give the assign or assign the IP address, and here I can use 192.168.1.2. I need to use a different IP address now. I cannot use the same IP address that was already given. No, I need to give the different IP address on the same network. Okay, and the default subnet mask will be automatically taken. Now I can say these two devices are not only connected physically but also logically, because I have provided the IP address. Now let us see. I need to check whether whatever the configuration I have done, I can communicate with the system or not. Okay. Now suppose I can go to this system number 2, and I'll be using one that is a application, that is the command. Open the command prompt and simply ping the device, ping. The ping is a utility from which we can able to check whether the destination system is currently available in the network or not. Ping stands for packet internet grapher. Okay, it will be sending certain ICMP packets to the destination system and getting the responses from the system, whether the destination system is currently alive or currently it is in off mode. You are getting certain error message immediately. Now see, I need to check whether 192.168.1.1 this system first system is available in network or not. If I hit enter, I'll be getting certain responses from the destination system with the size. We can observe it that reply from IP address 192.168.1.1. The byte size 32 is the byte size of ICMP packet. That is internet control message protocol. This is the only control packets. Okay, with the time the 2 milliseconds. So this time will be considered as a round trip time. That is the time taken by the transmitter to send the ICMP packet to the and echo back that particular response again back to the transmitter. So this particular time taken will be considered as time to the round trip time. The last ETL, the TTL stands for time to. There is a lifetime of your packet. How much your packet can survive in a network. If it is represented by 128 means it will cross 128 networks. Then and then only it will be dead in a nature. It cannot go beyond further. The lifetime packet is 128 nodes. Got it? And here at the bottommost part, you will be observing certain statistics. So by default, 4 packets are sent, 4 packets are received. So total lost will be 0. Here, whatever the packet we are sending is properly received by the receiver. But now see, now I am pinging one random IP address which is not available in network. So I am pinging 192.168.3. Now I'll be getting certain error message because that destination system is available in network. That is, I'll be getting this particular request timed out. Transmit able to send ICMP packets, but nobody is there in a network to respond to that, isn't it? So you are getting an error message, the request timed out, isn't it? So in this way, we can check the connectivity between the devices. Got it? This is the one simple example. Now I'll be going for one important topology as a burst, the star topology, where I needed here 4 computers. Now see, 1, 2, 3, and 4. I'm taking these 4 computers, and to connect to this, I'll be going to the network devices in a switches. I'm taking one network switch, and I'll be going to the connection, auto connection mode, and simply connect all the 4 devices in network switch. Yes. So these 4 computers are now connected to the network switch. So I can say these 4 computers are physically connected, not logically, because I haven't provided any IP address to the devices. Okay, so let me provide the IP address 192.168. Suppose 2.1. Okay, so 2.1. Here I can use 2.2. Here I can use 2.3. Here I can use 2.4, and the same I can provide. Go to the setting, go to desktop mode, go to the IP configuration. I can provide here 2.1 for the first computer. Default subnet mask for class C, same 3 times 2550. It will be directly taken by the system. Go to the second system, go to the desktop, go to the IP configuration. IP address of second computer is 2.2. Okay, subnet mask is same. For third computer, same, that is IP address is 2.3. I am changing only the last number. Rest of the numbers are same. And for last one, I'll be providing 192.168.2.4, and the subnet mask value is same. Means now I have provided the same IP address, means the 2.1, 2.2, 2.3, and 2.4, different unique IP address to all the respective systems. Now let me tell you, now by pinging one of the IP address, now from 2.3 I am pinging to the 2.1. So ping 192.168.2.1. Now let us see. Yes, we are getting a responses from the destination system. That system is available in a network. So you can ping, depends on how many computers are connected, but I'll be showing it here, a real-time condition, the simulation part. So you're going to the simulator that is available on the rightmost bottom portion, and click on the edit readers. Here you are observing the varieties of protocols, but I needed only ICMP for pinging purpose. So I'll be only selecting the one ICMP packet, and rest of the packets I'll be removing it. Okay, so here varieties of different protocols are available, depends on the applications. You can use them and design your own kind of application. Okay, so for our application I only needed ICMP protocol, so rest of the protocols I need to manually uncheck. It will be taking a time, but we need to do that. And suppose my destination system is suppose this, that is 192.168.2.3. I'll be clicking this, and this will be considered as the destination system, isn't it? Now see, on the right side there is a play button will be there. If I click on this play button, the packet will be coming from this particular PC1. It will be received by the switch, and from the switch that directly sent to the destination system. And once that destination system receives the packet, it will be providing the acknowledgement back to the switch and again back to the system. Okay, now let us see. I'll be clicking on this play button. Now see, packet is coming to the network switch, and now network switch forward that packet to the destination system, only to that particular system. And the destination system will again sending back the acknowledgement to the network switch and again back to the transmitters. Now see, yes, it is going, and you'll be getting a right tick here. Means whatever you are sending here, now see, you'll be observing the transactions also. And if I want to see in details, I click on this option, and this option is for getting the information. As we are aware about, ISO-ASI layer consists of 7 layers. Now the bottommost will be considered as a fast Ethernet. Second most layer is a data link layer, where the physical address or MAC address will be shown. The third will be considered the network layer. The transmitter source IP is given 2.3 and destination IP is given 2.1. So it is the acknowledgement. That's why it is showing as the in a reverse way. Okay, now this is the one case where the packets can be moved from the source to the destination. In the same way, now let us see, with the help of this cross button, I can delete the kind of connectivity I have made. Now suppose I am deleting this and taking a new devices in a network. And now instead of network switch, I'll be taking now the hub. I need to tell you why I'll be using currently the network switch instead of hubs. What is the drawback of using the hub, isn't it? So I'll be using here 1.168.2.1. So it is 2 remaining. Okay, so I'll be simply going to the same configuration, providing the same IP. Here also desktop. Here it is 2.3. And now I'm connecting it. Now see, all the 4 computers I have connected now. I go to the simulator, isn't it? And I'll be now selecting one message, and now this system acts as a transmitter, and this will be again a receiver. Now see, I'll be doing the same kind of example or doing the procedure that we have used for your smart topology using the network switch, isn't it? I need to highlight why the switch is more smarter than her, isn't it? Now see what happened. Whenever I'm clicking on the play mode, the packet is coming from this device to the hub, and this hub will act as a broadcasting, and it will broadcast this particular message to all the remaining computers. But our expectation is this packet should be sent and received by only the one destination system. Now see how the packet is broadcasted. Now I'll be clicking on a play mode. Now see, the packet is coming to the hub. Now hub will see how it will be broadcasting the message. Now see, I have only showing here 3 computers, so it will be sent to all the 3 computers, but here it will be going. Now acknowledgement is only coming from the destination system, but again it will be forwarded. Now let us see. The acknowledgement is also forwarded to all the devices in network, but that message and acknowledgement is not for other computers. Now in that way, hub is not smarter. Hub doesn't consist of any kind of switching tables or kind of routing tables, but your switch does it. Your network switch consists of switching table, and by doing the transaction, your switching table will be filled, and your network switch becomes more smarter. And next time that particular device knows that the packet is belonging to its system, and it will only forward that packet to that destination system instead of broadcasting every time in your network, isn't it? That is, I can say, switch is more smarter in nature. Got it? So in this way, I'll be I explained what is the purpose of going for the network switch and network hub. Okay, and why network switch is smarter than the hub. After that, I'll be showing here the 4 different kinds of implementation, isn't it? The very first implementation, take an example. If I want to create a web server, how I can create it? If I want to create a DHCP server, that is dynamic host configuration protocol. So initially you should know what is meant by DHC. So DHC server will automatically assigns the IP address to destination users. Take an example. In our laboratory, I have only 10 computers. So I can manually assign the IP address. There is no issue. But if suppose I have thousands of computers, so it becomes very much easier task for me, or being a network administrator, I cannot assign manually all the 1000 computers the IP address. So instead of that, I can create one server and assign the responsibility of being a DHCP server to assign the IP address to the destination system automatically. Okay, so this DHCP server assigns the IP address to your destination system automatically once they are booted up. Okay, so once that is the first implementation, we'll be observing how we can create a web server. Second, we can say the DHCP server. Third is the DNS server, isn't it? DNS is domain name system. So as I said earlier, the devices can be identified by IP address. So we human cannot remember the numbers. Instead, we can easily remember the names, just like a google.com. We don't know the IP address of google.com, isn't it? So we easily remembering names. So one naming system was developed, and instead of having the IP address, we simply remember it by their names. Okay, so how to configure it, I'll be showing that. And finally, how to configure an email server. So here 4, one server does the functionalities of here 4 servers, that is a web server, DHCP server, DNS server, and email server. Now let us see. Now what I needed here, I needed one server. I go to the again real time, okay, and I click on connected. Audio connected restore. Sorry, actually due to again network connection, I logged out. Okay, and my I think you'll be observing the contents. Okay, yes, yes. We can now see here the 4 different aspects how we can create a server and assigning the separate authenticity, that is it will be acted as a web server, DHCP server, DNS server, and email server. The 4 respective configurations can be done with a single server. Now let us see how I can do it. Now I needed one simple server. Now I'll be taking that server here. Okay, and what I needed, suppose I needed here 4 computers. Yes, I have taken here 4 computers, and to have this kind of a topology, so I can use here star topology. So I can use network switch, a 24 port switch, isn't it? So it's a 2950 20 port switch will be showing here, and I can connect this with the help of cables. Now automatically now see it's a straight cable is needed, that can be identified. For rest of the devices, straight cable is needed because there is a connection between computer to network switch. Both are the 2 different devices. Now once the IP, now the physically device IP the connection is made, I need to provide the IP address to them. So initially I need to configure the server. So I go to the server. Here you can have the server CPU. Here we can have the LAN RJ45 jack. Here we have the on-off switch. Okay, and I need to configure it first. So I go to the interface and fast Ethernet. or I can go to the desktop and provide the IP address of the server. Suppose 192.168.1.1. So this is the IP address of server, and I am considering this IP address as a default gateway as well as your DNS IP address. Okay, so I'll be providing different authority or responsivity to their server. Okay, now I assigned that particular IP address. In the same, I need to, so this will be act as an DHCP server. So for that, go to the services. Here varieties of services are shown, and DHCP is one of them. So dynamic host configuration protocol. So what it will be doing, it will assigning the IP address to rest of the 4 computers automatically. Now how you can see, simply you need to on this service, provide the IP address of the server 192.168.1.1. okay, and now see, I'll be going to the computers, go to the configuration, interface is a fast ethernet, and simply I'll be clicking on a DHCP. Now automatically now see IP address will be allocated 192.168.1.2. In the same way, I'll be doing the same configuration to rest of the computers. I'll simply click on a DHCP instead of static. Okay, so 1.3. Here you'll be getting 1.4. So sequentially IP addresses will be provided. Now you'll be getting here 1.4. Now see. And for finally, here you'll be getting 1.4. Sorry, 1.5. Okay, now means what? Now these systems can be able to connect directly to the server. Now I simply pinging it, go to the desktop, go to the command prompt and ping the server. So ping 192.168.1.1, and now see, you'll be getting responses, isn't it? Means now you are logically, physically as well as logically connected to the server. Okay, now the first task is done, that is how your system acts as a DHCP server. Now how you can create a web server? In that case, what I need to do, I need to click on the server, and under the services I need to click on STTP, that is hypertext transfer protocol. I need to create certain web pages, isn't it? So you can create your own HTML coding. Now I need to open the notepad. Okay, suppose I'll be writing certain so I need to terminate that body by writing /body. Any command if you are started, you need to terminate it. Now suppose I want the header first, h1, as a Pimpri Chindwad College of Engineering, Pune. Okay, so I need to terminate it, that /h1. Suppose I'll be taking another heading h2 as a welcome, or instead of that we can say Department of Electronics and Telecommunication, and I am completing it by h2. Next, suppose I needed certain kinds of movable statements, so I can use the marquee command. So welcome to 1 week STTP Technovators 2020. Okay, so I needed this particular small kind of movable kind of command or statement, and I can going to I'll be going to save it with the help of any name, and the extension should be HTML. Okay, so test.html, I'll be saving it on a desktop. Okay, now I'll be showing you that. Now see, if I'm opening it on any browser, the website will look like in this way. Now see, we can have the Pimpri Chinchwad College of Engineering, the first header. Second header is the Department of Electronics and Telecommunication. and third is a marquee statement, and which will be movable. Now I need to use this particular code. Now I'll be simply copying this code and going to our example. Under the services in the HTTP, now you need to select this on option here, HTTP as well as HTTPS, and I need to modify only this index.html. So I click on the edit and paste that particular code over here and save it. Okay, now once you've saved it, now click on any receiver device and you have the option here as a web browser. Okay, click on it and you should provide the IP address of a web server. So IP address of web server is 192.168.1.1. Once I hit enter, automatically whatever the web page designed on your server will be automatically fetched, just like we are fetching the Google server. Okay, you can use or you can access that web page from any of the system connected to your network. Okay, so I'll be showing you on another kind of device, 192.168.1.1. now see, immediately that web page will be visible to you. Okay, so in this way you can create a web server. Now the third one is a DNS server. Instead of remembering, so I cannot remember every time the IP address of a server. So how I can remember it by name? Okay, so on a service says you have the third option of DNS. Simply click on it. You need to start this DNS server option, and here you need to provide, suppose www.pccoe.pune.org. Now this is suppose the name provided to the IP address 192.168.1.1, and simply you to provide the IP address here 192.168.1.1, and you need to add it. Now it will be added in the record file. Okay, now if I go to the A computer, destination computer, click open the web browser, and instead of writing the IP address, I need to write here www.pccoepune.org. Once I hit enter, now see, you'll be getting again a web page that I have designed on a server. Okay, so this is nothing but your third service, that is the DNS server. And finally your email server. How to configure the email server? So you needed three different protocols to design the email server. First is DNS, second is POP3, and third is your SMTP protocol, simple transfer protocol. Now if you are observing in a service mode, you have the email. Okay, so you need to select the SMTP service on, POP3 service on, and you need to provide here the domain name. Now suppose pccoe.com is the domain name I want it, isn't it? pc.com. I need to set it first, so click on a set, and here create your users. Now suppose first user is AAA, password I am providing suppose 123. I'm adding it with the help of this plus symbol. Now this user is now created. Again I'll be using another user BBB, password I am creating 456, added. Now what I have done, I have created here two users, AAA and BBB, and I have started the SMTP server and POP3 server, isn't it? I need to create only this configuration. I need to done this configuration on the server. Now what I'm going to do, now go to the client system, and under the desktop you have to choose one email client. Okay, so here by default email client is there, so I need to fill up this information. Now suppose this is AAA. Now email address is AAA@pccoepune.com. Email address server, incoming server is the IP address of the system server 192.168.1.1. so I'll be simply copying it and providing the username as AAA and password as 123 and save it. Now on our system I have saved this particular information. Now suppose on another destination system, suppose this is a BBB system, I can go to the desktop and using the email client here, and this is a BBB. address is triple B at the rate of PCCOE Pune dot com. The IP address is same 192.168. That is incoming and outgoing server IP, and triple B is the username and password is 456. Now I have saved this, isn't it? Now what I need to do now, this is the triple A user, this is a triple B user. That is the name assigned. Okay, now this AAA system wants to communicate certain messages to triple B. Now I simply go to the email client, and here I need to compose one email. Now I click on a compose and writing the destination email address as the triple-e@the-rate-of pccoepune.com. Now suppose I am writing the subject as a test and the content of message, hello, how are you? Okay, so simple message, and I'm simply click on the send. I think the domain name configured server is not correct. Okay, let me check what is the domain name created. The email address PCCV, sorry, the pccv.com. I have taken pccpune.org or so pc.com I have created. Now what I need to do, simply I need to configure it. So instead of PCCV Pune, I have only provided pc.com. Save. On a destination system also, I need to do that particular change. So configure mail, pc.com, save. Now I go to the AAA system and writing an email, go to the compose, triple-b@pccoe.com, test, hello, how are you? Okay, once I send it, that message will be sent. Now on the receiver system, I need to check it. Okay, now if I click on the receive, automatically that mail will be fetched from the server, and now see the subject is a test and which was sent by AAA@pc.com with the message written, hello, how are you? Okay, in this way we can assign the role, different roles to the single user. Okay, now this server will act as a web server, a DHCP server, and a DNS server, as well as email server. So we have implemented only here a single server will be capable of doing these four responsibilities. Got it? Now next thing I need to highlight how to configure a Wi-Fi router. Okay, so I thought that it's clear from my side, as well as you understood how to assign these roles to the different, to the one server. Okay, now let us begin with the next example, how to configure a Wi-Fi router, isn't it? So what I needed here, I need to click on a network devices, and here below this wireless device category, I have the Wi-Fi router. I'm simply taking the Wi-Fi router. Okay, and what I needed again, the end devices I'll be taking as laptops. I'm taking suppose 3 laptops over here. 3 laptops, isn't it? Now I need to wirelessly connect the 3 laptops with this router. So I need to click on the router first. This is a kind of router we can have here on-off switch, one internet connectivity RJ45, and here 4 LAN port where you can connect your devices. Not only that, also we can go to the configuration. We can have 2 point under the wireless 2 point. We need to provide here SSID. So SSID is basic service set identification number. So it is the name of your Wi-Fi network. Suppose I'll be providing it as access point. Now suppose this is the name given to my Wi-Fi, that is access point. Okay, so I have copied that particular name and I can simply go to the receiver laptop. Now see, on the left hand side you'll be observing the screen of laptop, and at the bottommost part you have the keyboard. Here you can have the on off button. Now see, you can also hear the green kind of LED blinked. Here you can have your RJ45 jack. But what I needed here, the Wi-Fi wireless antenna. So I'll be removing this and taking it here, and the wireless aerial jack, I'll be connecting it here. But I need to do it by shutting down system. So I'm again starting the computer, isn't it? Once I started the computer, I go to the config file, and then under the wireless, I need to provide the name of SSID as access point. So I have taken copied it earlier. Okay. Now see, once I have given it, will be observing this router is now wirelessly connected with the help of this particular dash lines. Now this computer is now connected to this system. Now if I'll be showing the IP address of the router is 192.168.0.1. Okay, so I can write this IP address here for you, 192.168.0.1. This is the IP address of the server. Okay, so I'll be writing it here, and it will be showing here the IP address of the laptop received from the router, because router acts as your DA server. So it's automatically assigned IP address to your laptops, isn't it? So automatically, because we're having certain configurations. I'll be showing that configurations once after this experimentation. Now see, it will be getting the IP address 192.168.0.100. So 192.168.0.100 is the IP address assigned. In the same way, I need to configure for the next. I need to switch it off, remove RJ45 and plug here wireless jack, and then start it to the configure file. Under the wireless, you need to paste here access point, isn't it? And now see, automatically now this system now will be connected directly to the router. Now see, we'll be observing it with the help of this wireless connectivity. The IP address will be taken, will be 192.168.0.101, 192.168.0.101. In the same way, I need to configure for the next. Shut it off, remove this, join the antenna or PCI card, wireless, here paste it, and now see, the system will be again direct connected. Now see, means here virtually now IP address will be taken, it's a 192.168.0.102, and for this 101. Yes, now I'll be writing the IP address here, 102. So I have now see 0.101 the IP address of a router, and 100 to 101 and 102, three are the three IP address assigned by this route to the computers. Now let us see by ping it whether this system is connected. Now go to the desktop, I'll be pinging it. So ping 192.168.0.10. now see, we'll be getting a responses. Time taken will be somewhat higher, 11 milliseconds, 42 milliseconds, because all the devices are connected wirelessly. So each packet may travel its own path, depends on the availability of the resources, and you will be getting back the acknowledgement. Okay. Now let us see. Suppose normally in a house you are having a Wi-Fi router. So how to give access to the devices and how to restrict them. Okay. So I'll be showing it that. So go to the Wi-Fi router setting, click on Wi-Fi router, and you have the option of GUI, that is graphical user interface. You can, so this is the firmware installed in your Wi-Fi router, isn't it? So some firmware is, so what you need to do, so here you will be showing the IP address of this router is 192.168.0.1, and yes, I have written it here for understanding purpose. With the default subnet mask is 3 times 255.0, which is nothing but is a class C kind of IP, and DHCP server is, yes, it is enabled. That is why the receivers will be getting the IP address automatically. Okay, and finally we can have the starting IP address is from 100, and the maximum number of views connected you can change it, but here it is by default 50. So 50 computers can be connected to the Wi-Fi router. So that's why your starting IP address is 192.168.0.100 because it is starting from 100, and 50 computers are connected, means 149 computers, means 100 to 49 means total 50 computers can be connected to your network. Got it? Now see, under the wireless category, now see you have here the wireless tab. Click on it. You can provide here the credential. Now it is under 2.4 gigahertz because whenever you purchase any router, you need to see whether it is a single band or dual band kind of router. Single band, it is working on 2.4 gigahertz of frequency, where dual will be working on 2.4 gigahertz as well as 5 gigahertz of frequency, isn't it? Now see, you need to provide the name of the Wi-Fi. That is the point I have provided. That is a service set identification number or name. Okay, SSID belongs to the name of the Wi-Fi. Now enabled. Now what I'm interested in showing, the bandwidth will be depends on your whether you are required the 20 megahertz or 40. That can select it manually. You can have 5 gigahertz also. I'm interested in providing the wireless MAC filtering. Now you have here the option of wireless MAC. How to provide the dual security to your devices. Got it? Now I can simply click on a wireless MAC filter. Initially it is disabled, isn't it? Initially it is disabled. Now I need to click on the enabled, but before that I should know the MAC address of the devices so that I can give the privilege to them. Okay, now I click on a laptop and go to the configuration. Okay, so instead of this I go to the wireless and I get this MAC address. Now see here MAC address is shown. Now simply copy it. Okay, but I needed, because the MAC address are written in a proper fashion, so it is a 12-bit number. Okay, and by a colon sign or a dash sign. So I'll be making it after 2 hexadecimal numbers, 1 colon symbol will be there. So total 16, I think 16 hexadecimal numbers are there. So I'll be copying it, and I now go to the server. This is your Wi-Fi router. Under the wireless, you can go to the wireless MAC filter, and here you need to enable this MAC filtering, and below you can paste the MAC address which you have copied, and you have selected this option, that is prevent PCs listed below from accessing the wireless network. Means you are going to prevent any device which should not be connected to your network, isn't it? So after you simply click on a save setting, okay, that system only disconnected from the network. Now see, this system is disconnected and you cannot get the access of your Wi-Fi router. Now you cannot see this connectivity. Here you can have the connectivity. It will be showing it by the lines. Okay. Now see how I can make it reverse. Instead of this preventing, I can permit only that system. So whatever the computers, laptops, your mobile phones you are using at your home, simply copy the MAC addresses of all the devices and paste it here in the firmware of your Wi-Fi router, and simply click on save. Once I click on a save, these 2 connectivity lines will be disappeared, and only the router is connected to your first computer, only single. Now see, click on a save. Now see, now the laptop 2nd and 3rd will be disconnected automatically because I have given the privilege. I selected the option permit the PC listed below to access this network. Means I only copied the MAC address of this device, and that can be accessible and connected to the Wi-Fi router. If your Wi-Fi router is having internet connectivity, automatically the laptop will receive that internet connectivity from the router. Got it? So this is regarding your the simulation of Wi-Fi network in Cisco packet, as well as the MAC address filtering in your Wi-Fi network. Isn't it? So these are the four simulations I need to show you, isn't it? So I think everything is clear from my side regarding the computer networks. And if you're having any kind of query, you can send it on your Telegram group or on a same platform by clicking on a question mark. Because this is the thing regarding your computer networks. There are so many things are there, but due to the time, we cannot go beyond. But the next part, I think the Internet of Things. We need to go to the Internet of Things as well. I'll be taking a 5-minute pause here, and after that, we'll be coming back to see what IoT, and I'll be showing certain examples and one practical and a simulation also Internet of Things on IoT. Thank you very much. It is okay. We'll be taking a 5 minutes break. Thank you. Yes, yes. Starting. So, am I audible to all? Okay. And is screen the PPT is available? Is visible to you? Okay. Thank you very much for replying. Let us start with the new content. That is, what is IoT? And I'll be going to explain you with taking a few examples. That is automation and the help of simulation as well. So I'll be showing my hardware also, how I have designed this particular small experimentation. You can also do the same thing at your home to operate different kinds of appliances. Now, before that, you should know about what is actually Internet of Things, that is IoT. Now, here I have shown one kind of slide where all the devices, your daily routine devices, any appliances such as your cycles, mobile phones, or keys, or your vehicle, transportation, buses, everything, multiple devices, we can make these devices smart enough and they can connect it to a single network, and that will be considered as an internet. Okay? All these devices are connected and exchanging the information over the internet, isn't it? So thing means any device, and that might be your mobile phone, that might be your laptop, or any kind of smart gadget, your pen as well. Any device can be able to exchange the information to and from the cloud, and which is directly connected to the internet, isn't it? Now here, how we are able to share the information from these smart gadgets? What are the different things are available in the Internet of Things? Now, varieties of different companies have given the definitions of what is meant by IoT. Now, one of the reputed company, the European Commissions, have defined the IoT as from a network of interconnected computers to a network of interconnected objects. Currently, we have discussed what is meant by computer networks, where the computers are connected and form a network and able to exchange the information to each other. In the same way, instead of computers, any kind of object that can be connected to the internet and may be able to send or communicate with the messages. Okay, the simple definition provided by the European Commission. What other definition defined by the Auto ID Labs? The basic idea of IoT is that virtually every physical thing in the world can also become a computer that is connected to the internet. What is the meaning of this particular definition? Any device, if it's connected to the internet, is a computer or any kind of computational device, isn't it? Means any small object, if it is exchanging the information onto the internet, becomes a smart gadget or smart computers. Got it? Next one, one of the renowned name in computer networking or IoT ecosystems who have defined this first statement. IoT is simply the point in time when more things or objects were connected to the internet than people. Now see, currently the scenario is different. Traditionally, scenario was different, isn't it? Earlier, traditionally, people used to have only mobile phones or small kind of devices that can be connected to the internet. Suppose the computers, only computers were there. But nowadays the situation is different. Every individual will be having 6 to 7 gadgets with them. Your mobile phones, your the smart watches, the badges. We can have your different kinds of gadgets with you. Okay, the spectaculars, everything. So means every individual will be having more than 5 to 6 objects, and all these objects are connected and sharing the information onto the internet via different wireless enabled technologies such as Bluetooth, Wi-Fi, Zigbee, or your WiMAX, anything. There are varieties of wireless technologies available. Depends on the applications. And the last one is very important, which is defined by the TC, Staff Consultancy Services. The definition of IoT is a worldwide network of interconnected objects, uniquely addressable based on the standard communication protocol. So this is again one of the important definition provided by TCS. What is the meaning of this definition? Your worldwide network. So what is your nothing but your internet? It's a connected, interconnected objects which are uniquely addressable. As I mentioned, every computer requires one unique IP address. The same thing, every individual devices, smart gadgets should require a unique address. Okay, so every individual system, every smart gadgets requires one unique addresses, and that can be based on any one standard communication protocol, isn't it? That might be different, depends on your application. Take an example of smart dust, isn't it? Whenever I am talking about smart dust, so we are observing things as the internet of nano things, where your devices becomes very small micro level designs, isn't it? Where your sensors are interfaced with your devices, and then they will be communicating with your internet via different wireless enabling technologies such as a Bluetooth. Take an example of smart dust example. If you insert that small particle grain like structure in our human body, then that will be monitored the actual internal health of our individual body of human, and real timely they'll be sending the information on your mobile phone with the help of Bluetooth technology, isn't it? So now the doctors will getting the information effectively what is going on inside the body of a patient by using this particular smart nano internet of things technology. Okay, so every device should be uniquely addressable and must be using one standard communication protocol. So without protocol, your communication will not be possible. So at least you need to use one unique kind of protocol or follow unique kind of protocols. There are certain kinds of pillars are there for the Internet of Things. The very first thing, your IoT should have a communication. Okay, it should have the communication property. It should communicate with each other. Any smart device, it should be capable of getting the information from the environment with the help of sensors and convey that information to rest of the devices. So it should have this particular property of communicating with different devices. Second pillar will be talking about the processing, isn't it? So your device should be capable of processing the data which is received by whatever the raw data received by the sensor. So it should process it, it should extract the relevant important information from it, and then it can be communicating to the different devices or onto the cloud. Okay, the third one is related to the identification. Every IoT device should be identified on network, so it should have a unique IP address. Then and then only device can be identified. So take an example of a sensor network. It is the base of your IT. So in wireless sensor nodes or networks, varieties of nodes are there. It should have a unique identification number, that is IP address, so that it can be easily tracked or identified. Next one is the localization. How you are able to find out the location of the devices. So with the help of GPS, for example, you can easily track what is the actual location of the particular devices. So you can use it in your different applications to track the animals, to track the birds, isn't it? With the help of localization feature of IoT boards. And finally, the storage. So your IoT development board should have the storage capability, isn't it? So if you extracted some important information, so you should process that information and store locally on your device, and last one you can upload onto any cloud. So depends on our requirement. Okay, and side by side you can have your security. Okay, the security is the main concern of your IoT device. Any node, if you are saying it is connected to the multiple nodes, they should be having a great security aspect. Means no hacker will going to hack the content of the nodes, isn't it? The security will be side by side, plays a very vital role in IoT platform. And later one we can have at the bottommost part will be nothing but the input side as in sensor, output part as in actuators, and the intermediate part as in your processing board. Okay, so any embedded device will be capable of exchanging or processing the data, will make the device smarter device. Next one we can have the structure of IoT. So these four structures should the IoT device uh, it should consist of. So very first is it should have the tagging the things. Okay, any devices can be traceable or that can be accessible with the help of this particular technology. So one of the technology RFID type kind of technology, or you can use instead of RFID you can use a Bluetooth, Zigbee, any kind of wireless enabled technology to tag different the IoT devices. Okay, so one of the kind of structure of your IoT. Second one, your IoT system should have a feeling the things. Okay, so can provide the feeling so with the help of the sensors. So sensor plays a very important and vital. Without sensors your IoT will not work. Okay, so what are the environmental parameters change that can be detected by the sensors, and the data will be broadcasted on your cloud. So sensor makes as your primary devices which should be capable of collecting the information from the environment. Got it? Now third one structure is shrinking the things. Means as I mentioned earlier, we are using currently the different kinds of IoT development boards such as an Arduino Uno, Arduino Nano, Arduino Megas. Then you can have your Node MCUs, we can have the Raspberry Pis, we can have the Intel we can say uh, there are varieties of boards are available in the market, isn't it? So Beagle Bone. So based on that, we can depends on the application, we can choose these boards based on the size or the size of that particular device. Okay, and then finally it should have a thinking capability. It should have certain embedded devices that can be capable of processing the data, and that becomes a smart enough to upload the data onto your devices. It should take the decisions based on the inputs taken by the sensors, isn't it? And it will actuate certain things, isn't it, in consultation with the cloud. These are the certain structures of IoT you should know about it. And now I'll be showing one practical approach how you can design an example of home automation using IoT, and that I'll be showing it with the help of Cisco Packet Tracer. Okay, now what I'll be doing now, see what I'm needed here. I simply go to the wireless devices. What I needed here, the gateways. Okay, so if I want to control the devices in our home, I need a central gateway that will be act as your Wi-Fi router. Okay, through which your devices are connected. Now see what I'm going to do. I'll be using different devices. So from the home, I'll be taking, for example, a fan. We can get certain sirens. I'll be taking here one lawn sprinkler. I'll be taking again suppose a smart window, and finally suppose a garage door. I'll be taking suppose these 5 devices. I need to operate it manually from my mobile phone or my any kind of device, smart device. Okay, such as your tablets or your the laptops. So what I need to do, I need to connect all these 5 devices virtually to your gateway. So what I need to do, I need to first go to the gateway. In a configuration file, I should click on a wireless, and I need to copy this SSID of that particular gateway, okay, which is mentioned as a home gateway. Okay, so what I need to do, once I copy that particular information, I go to the device. On the bottommost side, you have the one option as advanced. I click on the advanced option. You'll be getting this tab activated automatically, IO configuration, and simply I need to use here the wireless PCI card as a PTIoT NM1W. Once I selected this option, I go to the configure file, okay, and I'll be selecting as a DHCP, and here the home gateway. Okay, once I do this, now see this fan, smart fan, is now directly connected to the home gateway wirelessly, isn't it? In the same way, I'll be connecting all the rest of the devices. So I'll go to the siren, I click on an advanced tab, I go to the IO configuration, select that wireless PCI card, I go to the config, select the DHCP option and the gateway as a home gateway. Okay, now see automatically the siren is also get wirelessly connected. Third one, the launch sprinkler, I'll be following the same kind of thing. Click on advanced, IO config, 1W, in config, DHCP and home gateway. Third one is also gets connected. One smart device, so that's a window. Follow all these configurations. 1 minute. The DHCP home gateway. Now the final one. Go to the config, DHCP, and finally the home gateway. Now see, if you're observing, all the 5 devices are directly connected with the home gateway now, with the Wi-Fi or wireless technology. Now I needed something, take an example, under the end devices, suppose taking a smart tablet or your mobile phone through which I need to operate these devices, isn't it? So this mobile phone should be connected to first my gateway. Okay, so what I'll be doing, I'll be following the same kind of thing. I go to the config, go to the wireless, I'll be writing the SSID as the same SSID name that is of your gateway. Okay, now after that, yes, DHCP is now selected, and now see my mobile phone is now directly connected to your home gateway. I'm checking it once again. Wireless, yes, everything is fine. Now what I need to do, I need to now operate all these 5 different what you can say, the appliances from my mobile phone. Now I can go to the smartphone, and in a desktop mode I'll be having option of IoT monitor. Okay, I can click on this IoT monitor, and I need to provide the IP address of my home gateway. Okay, so if I'm the cursor on this particular home gateway, you can check the IP address. Will be getting 192.168.25.1, which is directly identified by that particular software with the by default username password as admin and admin. Okay, and once you click on a login, now see automatically 1 2 3 4 5 devices are now shown, which is connected to the network. The first device is ceiling fan, second is a siren, third is a lawn sprinkler, fourth is a window, and fifth is the garage door. Now if I want to operate this plan, simply I click on a ceiling fan. I have the 3 options: off, low and high. If I click on a low, now see it will be showing certain speed indications. If it is high, now see it will be showing again the fan is rotating like a symbol. Now second most is a siren. If I start the siren, now see automatically the color will be changes to the red, means now the siren is started. In the same way, the sprinkler, if I do the command to turn on the sprinkler, now the water is sprinkled, and finally we can have the window. If I click on the open window, now this particular window will be operated. Now see, it is on off. Okay, and finally the garage door, if I click on open the garage door, this particular garage doors will be opened and closed. Now in this way, with the help of any smart gadget, you can operate any appliances if it is connected to the common gateway. This common gateway acts as an access point where all the devices are connected. So by doing certain small configurations, you can directly be the virtual part of that particular network, isn't it? So this will be the part of your IoT with the help of your Cisco packet tracer. Okay, the same part I'll be showing it with the help of your actual part. Now see, I'll be using here a Node MCU. So if you're observing a Node MCU, it's a very small chip. Will be having inbuilt ESP12E chip, which is capable of inside Wi-Fi chip, which will be operated on 2.4 gigahertz. Okay, and which is maker of this particular of frequency. Okay, and this particular Node MCU will be having the analog pins, some digital pins through which we can configure our circuitry, or we can connect our circuitry. Here this board can be powered with the help of micro USB cable, or the port is available here. Not only that, but also we'll be having here flash and reset button to flash the but also we can have the serial communication with the help of this CP2102 is a kind of converter, the USB to TTL, and we can also have onboard LED. Okay, so whether your board is currently working, that will be shown on the LED blinking. You can have the small inbuilt program also to LED blink it on or off with the help of this particular LED. Okay, this simple introduction. Now we can have here the detailed information regarding the Node MCU. The pin configuration will be shown here. Out of that, we can have the power on board, and so V in as a 5 volt and 3.3 volt will be available on the board. We can have the control pins of a reset and a flash. We can have a single analog pin A0, which will be capable of connecting your analog sensor. We can have here 16 GPIO pins. Okay, you can observe it, GPIO 1, 2, 3, 4 up to 16. So we can use these pins to connect any external circuitry to this particular data pins. And we can also having the SPI communication, serial peripheral interconnection. Okay, and but also we can have the UART connection to upload your small code into this particular chip. Okay, according to that your system will works. Okay, this small configuration on a Node MCU. What I have done, I have used the Node MCU over here, and I have interfaced here the fan. One small CPU fan will be there, which will be directly connected to the relays. The buzzer will be showing. The bulb is here directly connected to the board via this relays, and with the help of Blink Cloud on the right hand side, I'll be showing you the application that is on my Android phone. That is a home automation using the Blink Cloud. Now for that, I'll be showing you how you can create this particular contents. Okay, so what you need to do, simply go to the Blink. You will be showing, sir. So I need to open the Blink application. Whenever you are doing this first time, what you need to do, you will be observing this the options first. You need to click on the new project. Now, once you click on a new project, you need to provide the name of the new project. Now, suppose I'll be providing the home automation. Okay. After providing the name, I need to select the kind of board on which I am doing this particular experimentation. So in this particular part, I need to use the Node MCU, isn't it? So here the Node MCU will be there. Okay. So I'll be selecting the Node MCU. After that, a kind of connection needed. Okay. So this symbol will be taken because I'll be using a evaluation version of the software. So behind this, you'll be having a Wi-Fi connection. So yes, your Node MCU will be having Wi-Fi connectivity. So I can use the theme as a white or a black, and I can create it. Okay, once I create it, one token number will be sent directly to my email address. Yes, once the token number is sent, I need to copy that particular token number, isn't it? And I need to use it in my program. Now I'll be showing you that. Now open the Arduino program, and you need to write here some small code. So I'll be not going into details about how to write that particular code, but I'll be showing it on a sample example. So you need to go to the visit to the examples.blink.cc. Okay, so once you click on this particular, go to this particular web portals, you need to select on the left hand side what kind of boards you are using. Now suppose I'll be using here Node MCU. What kind of connections you are using? Okay, ESP8266 Wi-Fi. If you're having a token code which is received on your email, you can write it here, or later on you can edit it. And you can have here varieties of the sample codes available. Okay, now suppose I am using this blink. Okay, now at the last option, I'll be getting the code directly. I'll be simply copy this particular code, and here what is needed. Now see, your authentication token code which is sent on your email address, simply you need to paste it here. You require your SSID, that is the Wi-Fi name of your hotspot. Okay, and the password associated with that particular hotspot. Only these three things are needed. The rest of the things, the baud rate will be selected as a 9600, that you can choose it while connecting your board, your computers. So simply you need to copy it and paste it in this Arduino application. Okay, now see, it is visible. Now see, under the character authentication code, I have copied what is the email, what is the code that is received on my email address. Simply I have pasted it, and what is the hotspot name and the password associated it, I have only simply pasted it here. Okay, and once I have done the correction into this particular code, simply I need to verify it on clicking on the right side. You need to upload it by using this arrow, but you need to mention, you need to connect your Node MCU to the laptop or your computer with the help of USB cable. And not only that, but also you need to write or install the Blink libraries, okay, for this particular code. So how you can download this Blink library? Go to the sketch, go to the include library, you can click on a manage libraries, and in this particular manage libraries you need to write the Blink, and automatically the libraries will be available. So simply click on install, that Blink libraries will be automatically installed on your device. Then only you can import all the necessary functionalities associated with the Blink cloud platforms. Okay, so I have already installed it, so I'm not showing it. Now what I need to do, once it is installed, now you need to configure it. Now see how I'll be going to configure it. On a mobile phone, once you using the Blink application, you'll be getting certain points to you. That is a free of cost. Currently, it will be showing 400. Okay, that is a charge, minimum energy charge with your. But we are having maximum value. But here I have used many of the buttons, so it will be showing only 400. But I'll be showing you how I can use it. Now, simply I'll be clicking on this positive sign to import any specific button. Now, see, I can click on the button plus sign, and I suppose I needed this button to operate any appliances, so I needed 200 energy charge. Now see, automatically this button will be available to me. Now I need to configure it. I click on the button. Now provide any name to that particular button. Okay, suppose it is AC. I need to operate the air condition. Now after that, this pin you need to select your node MC selected which pin of the application. Now suppose I am using a D4 pin. Now I'll be using a D4 pin to connect to the device, and I'll be using button as a push button or switch button. So I can use it as a switch button. Okay, and now rest of the things as it is. I simply go back. Now automatically this particular switch button will be yes formed. Okay, in this way I have created for the LED, for lights, for bulb, and for the fact. Test or customize it, you have this particular option to run your simulation. Okay, so once you run your simulation, you can operate any kind of device. So I'll be showing it with the help of webcam. I have the setup here. Sir, is visible setup with the webcam? It is somewhat blur. Okay, so now here it is visible. Now see, I think it is visible or not somewhat. Okay, now suppose I'm clicking on, I think you will be observing the application on my. If I click on it, now see, automatically light will be turned on. Light will be turned on, and if I click on off, it will be turned off. It is turned on, turned off. In the same way, if I click on a LED, now the LED which is available on a board, it will be blink. Now see, now it is turned off, turned on. Okay, and regarding the buzzer, if I click on a buzzer, that particular buzzer will be played. Now see, I am clicking on a light. Now it is lights is on. Now I am making it is off. Automatically it will be off. In this way, thank you, sir. In this way you can. Sorry, due to the technical issues. In this way, you can create any kind of small application through which you can operate any kind of device with the help of different clouds. Here I have shown only the cloud platform as a Blink. Okay, this is one of the example. I think you understood what I am explaining to you. Okay, the next one regarding temperature using ThinkSpeak. So what you need to do, I'll be showing. I'll be DHT11, and with the help of DHT11. So DHT11 is nothing but the temperature and humidity sensor through which you'll be getting the real-time values of the temperature and humidity, and that we can observe it on the directly done this. If you purchase this DH11, you have the VCC ground pin and the not connected. Okay, so VCC you can provide connected to the 3.3 board. Your ground is connected to the ground pin of your node MCU, and VCC I am connected to the D1 pin. Okay, so with the help of this, now take an example. Again, I'll be going to the same Bleed Out platform, or you can now go to the thingspeak.com. I'll be showing you on the thingspeak.com how you can execute this particular experimentation.
वीडियो रिकॉर्ड केला आहे का त्या प्रॅक्टिकल?
नाही, मग
कधी चर्चा म्हणताय?
हां केलेलं. Okay, wait.
We will add video demonstration on group.
Yes, and definitely we'll be uploading all the videos about the demonstration, how we have done the experimentation. Okay, onto one Google platform, Google Drive, and definitely you'll getting all the videos rightly on to each and every participant of this particular STTP. Let me show you other. Yes, so if you go to the ThinkSpeak, so ThinkSpeak is again one of the application. It is visible all. Yes. Only PPT. Okay. Okay. So here, if you go to the thingspeak.com, what you need to do, you need to simply first create your login credential. So this ThinkSpeak cloud is from the MathWorks. And what you need to do, yes, you need to provide the email address credentials. Yes, so once you log into this particular ThinkSpeak cloud platform, you need to create your own channel. Okay, so click on this particular channel, new channel. Once you click on new channel, you need to provide here the name of that particular experimentation. Suppose I'll be providing experimentation temperature and humidity monitoring. Okay, temperature and humidity monitoring. In description you can write the details about your experimentation, but currently I'm not writing anything. In the field you need to write down which parameters you are measuring. Now take an example, temperature, the first parameter I want to measure. Second parameter, suppose the humidity. Okay, so only these two parameters are I need to measure. So rest of that you'll be getting total 8 fields. So that real time you can monitor different 8 fields. They have different sensors. The rest of the thing is not currently usable. Now I'll be using only this tab as a show status and click on a save channel. Now see the channel will be created with a unique ID of that particular channel, and I'll be getting one real-time chart of temperature and a real-time chart for the humidity, where I can monitor this particular. Okay, and the important things, currently we are in a private view mode. You can make it public by sharing it. Now click on a sharing option here also, or here also it is available. Share it, so you can share it to the some of the user, write it here email address, or you can make it public by directly selecting this option, share channel view with everyone. Okay, and now once you click on a public view, you'll be getting the option. Now see, directly this public view. Now previously we were in this private view. Now it is in the public view. What is important? This API keys. So that is application program interface. So what we are interested in, we needed the write API keys and read API keys. Okay, whenever I need to upload any data onto the cloud, I needed this write API key. Okay, so what I'm going to do, here we are having certain API request. I'll be copying this particular URL and simply pasting it here. and now it is observing that URL consists of field 1. So field 1 is related to the temperature. Okay, now suppose the temperature is 30, so I'll be writing 35, and once you hit enter, now it will be showing 1. It should not showing kind of a 0 value here. Value should be included. Okay, now once I've done this, you should go to the public view, and you can observe it here. I have manually entered one value as a 35. Now see, temperature I manually entered with the help of write API key. So 35 will be shown here. In the same way, I can write here as a field 2, and the humidity suppose 75, and I hit enter. Now see, that value is incremented. Now it is 2. And now if you go to the experimentation, and if you refresh it, if you refresh this, now see, automatically tag particular value of humidity of having a value 75 will be automatically taken. Okay, in the same way, what you need to do, you need to do these connections, and once you do these connections, simply upload the data, and real time we now see data will automatically shown on these particular graphs. The real time values will be uploaded onto the this particular ThingSpeak cloud platform, isn't it? So in this way you can do your the second experimentation. Okay, so that is regarding the humidity and temperature monitoring. Okay, so there are varieties of contents are available, how you can get the notifications and all these things. So you can have these particular contents through STTP, and how you are going to react on this. If certain events are occurred, then how you can react in this. Suppose take an example, if humidity exceeds 75, automatically I'll be getting a notifications on my mobile. So I can use other cloud platforms such as IF-Triple-T. If this, then that, or I can simply use IF-Fruit. Okay, these are the some open source cloud platforms are there. Okay, but I'll be not covering that in this particular session. Okay, so that's it about the two applications regarding the IoT kind of work, isn't it? So if you're having any kind of queries and questions, now see, I'll be showing these write API keys and read API keys. Okay, so if you want to access the data directly from cloud on your mobile phone, you needed read API keys, but currently I have written the data onto the cloud, so you need to use this write APIs directly. So in this way, I think this is the content of the session regarding the computer networks and the IoT applications. So I think if you're having any kind of query, you can raise it. Otherwise, we'll stop it here, because I'll be sharing my mobile number and email address. So if you have any kind of query ahead, you can directly contact to me, and we can have that particular communication, or a one-to-one kind of communication with the parties.
Or in upcoming time, we will also plan session on Raspberry Pi.
Yes, as we aware about this, we are having only a first STTP. This is the one only a starting of this particular platform. Later on, we'll be moving on a different kinds of platform. Take an example of introduction of Raspberry Pis, or different cloud platforms also. Okay, so this is the first series. That's why we are covering a very basic knowledge of all these things. In the next STTP, we'll try to get some advanced knowledge based on this particular platform. Okay, so kindly tune to our contents as well as the web portals, and we'll be getting soon with the next STTP. Thank you, and thank you very much, John, for being with us. And we'll be soon sending all the videos and of the sessions and the experimentation kits, and now we'll be sending the feedback forms also on your respective Telegram group as well as your WhatsApp group or your email address. So kindly attend it. Thank you very much.